Hello everyone. My name is Vivek and my roll number is 19951822197, studying in 6th semester in Aeronautical Engineering Department in Institute of Aeronautical Engineering. Today, in the subject of aircraft systems, the Tech Talk topic is about what's next form in ADS-B in the traffic system. So this is a basic schematic view of how ADS-B works. So here we can see an aircraft sending out its B, say B through waves, and it is being uh, captured by the air traffic services and through the receivers. So ADS-B is a new surveillance technology designed to help modernize the air transportation system. It provides foundational technology for improvements related for the next generation air transportation system and single European sky air traffic management. ADS-B stands for Automatic Dependent Surveillance Broadcast. Uh, the basic points through the ADS-B are automatic because it periodically transmits information with no pilot or operator involvement re- required. Dependent because the position and velocity vectors are derived from local positioning system GPS or other suitable navigational systems. Surveillance because it provides a method of determining three-dimensional position and identification of aircraft, vehicles and other assets. Broadcast because it transmits the information available to anyone with the appropriate receiving equipment. ADS-B replaces radar technology with satellites, bringing major advantages. Radar relies on radio signals and antennas to determine an aircraft location. It uses satellite signals to track aircraft movements. So, what does ADS-B mean? So, as we have seen, A, which is automatic, position and velocity information is automatically transmitted periodically without flight crew or operator. Other parameters in the transmission are pre-selected and are static. Dependent. The transmission is independent on proper operation of onboard equipment that determines position and velocity and availability of a sending system. Surveillance. Position, velocity, and other plane information are surveillance data transmitted. Broadcast. The information is broadcasted to any planes or ground station with an ADBS receiver. Current mode, which is SATC transponders, are interrogated and they send a reply. So it works on like this. ADS-B out. ADS-B out works by broadcasting information about an aircraft GPS uh, altitude, ground speed, and other data to ground stations and other aircraft once per second. Air traffic controllers and properly equipped aircraft can immediately receive this information. This offers more precise tracking of aircraft compared to radar technology, which sweeps for position information every 5 to 12 seconds. Radio waves are limited to line of sight, meaning radar signals cannot travel longer distance or penetrate mountains or other solid systems. ADS-B ground systems are smaller and more adaptable than radar towers and can be placed in locations not possible with radar. So this is how an ADBS works. So the aircraft with an ADBS transmitter sends its signals, and this is received by the receiver on the ground and the ground air traffic controls and other remote receivers. So, and the other is the ADS-N. ADS-B-in provides operators for properly equipped aircraft with weather and traffic position information delivered directly to the cockpit. ADS-B in-equipped aircraft have access to graphical weather displays in the cockpit as well as text-based advisories, including notices to airmen and significant weather activity. So these are the other services which are done through ADS-B, which is air surface traffic situational awareness, airborne traffic situational awareness, visual separation on approach, ADS-B traffic awareness system, in-trail procedure, cockpit display of traffic information, assisted visual separation. So ADS-B can increase safety, efficiency and accuracy of radar systems. The systems are supposed to benefit not only air traffic controllers on the ground but pilots and the general public. Broadcast systems are more reliable than radar system. This is important because radar systems are currently used to track airplanes. This can be seen as beneficial for many reasons. ADS-B do not have moving parts that wear out and have to be replaced, and use low power and have state of art digital radio technology. Typical radars have many parts that get worn out and have to be replaced. The radars typically require high power, and some do not have state of the art technology. For this, ADS-B are the more reliable and dependable one. Another problem with radars is that they do not work as well through bad weather and sometimes cannot reach maximum distance when the weather is bad. The ADS-B system is not affected through any kind of weather like the radars suffer. They can reach maximum range without being interrupted and affected by the weather. They can locate airplanes to thunderstorms and even in snowstorms. So, the next technology which are after ADBS-B are nothing but the new capabilities building on ADS-B technology, which is ACAS-X family of collision avoidance system, ADS-B version 3 and associated mode S transponder changes, ADS-B in capabilities, which is airborne surveillance application. By this, I come to the end of the topic. Thank you.